Then, as I said, as we have discussed now, that we have 3 states of matter that we are going to discuss. Means that we are just going to talk about thermal expansion of solid. Means how solids expands, how liquid expands, and how gaseous expands. And that is why for the first time now we are going to discuss thermal expansion of solids. That is to say, most of the solids expand when heated. When now you heat a solids, there is an expansion that may happen on that solids. Now we are just going to discuss how the effect of temperature may affect the expansion of the solid in general. And that is why now we have something. When the solid is heated, temperature is increased. When now you are heating the solid, the temperature increases. Means that you have heated, you have increased the temperature. Initial maybe it was 20 degrees Celsius. Now due to the heating of the solids, now the temperature have increased to 40 degrees Celsius. Now there is an increase in temperature. Now what is the result and what is the effect of the increase in temperature? Now when the solid is increased, the temperature is increased. Now the increase in temperature causes the kinetic particles to increase. Mean that you are increasing the vibration of the particles. Whenever now you are increasing the vibration of the particles, means you are just increasing the kinetic energy of the particles. That is also increased. Now due to the increase of the kinetic energy, means the vibration of the particles have been increased. Now the result, then the volume of the solid also increases. Now when the solid is heated, the temperature is increased. And the increase in temperature causes the vibration of the particles to increase. Hence you are increasing the kinetic energy of the particles. Also it is increased. Then the volume of the solid is increasing. The volume of the solid also increases. Now the increase in temperature increases the kinetic energy, increases the vibration of the particles. Then the volume of the solid also increases due to the increase in temperature. That results to the increase of the vibrations of the particles that exist in the solids. But also when the solid is cooled, that is vice versa. The vibration of the particles slow down. But when the solid is heated, the vibration of the particles increases. Means they move it too fast. And that is the result, its kinetic energy also is increased. But when a solid is cooled, the vibration of the particles slow down. The amplitude of the vibration is also smaller since the kinetic energy of the particles is decreased. Now, once you decrease the temperature, you are decreasing the kinetic energy. Now, you are decreasing the vibration of the particles. Now, you are decreasing the volume of the substance. That is, then the volume of the solid is decreased. But now we have said that we are just increasing once the temperature is increased, we expect there is a change in length. Because now whenever you're talking about volume, you discuss about the dimension of the solid. It may be volume, it may be length, it may be radius, it may be whatever, but you are just talking about the dimensions. And that is why there is a change in length. Change in length depends on the following factor. One, it depends on the length, original length of the substance. Now, the original length of the substance must be considered. That is to say, now change in length is that proportion to the original length of the substance. That is the first factor. Means what? Means if now you are increasing the length, if the change in length increases, it depends on the original length of the material. If now you have the shorter the length, the shorter the change in length. The shorter the length, the shorter the change in length. Now it bends direct to the original length, and that's why we say the change in length is the proportion to the original length. The second factor also we just have. The second factor we have to consider about change in temperature. Change in temperature. Now, the change in temperature also here is very important for us to be considered. Why is it so? Because we have said there is no change in length without change in temperature. Now, the solid now expands in the presence of change in temperature. That is why we say now change in length is that proportion to the change in temperature. Now, it is direct proportion, means it depends directly from the change in temperature. This is the second factor that we may consider. You get that point? But also, it depends on the nature of the material. What kind of the material now are you just burning? If now you're just burning plastic, you're just burning iron, you're just burning this and this. Now also the third factor is that is the nature of the material. Nature of the material. Now these three factors are the factors on which the change in length depends on it. Now one depends on the length, original length. The second depends on the change in temperature, and the third one depends on the nature of the material. Means what kind of the material are you just talking about. If now you're just talking about plastic, we have to consider about it. If now you're just talking about iron, we have to consider about it. If now you're just talking about copper, we have to consider about it. If now you're talking about aluminium, we have to consider about it. Now these are the three factors on which the change in length depends on. In case now you've been taught to explain the factors on which the change in length depends on, you have to mention one is the original length, and then the second is the change in length and change in temperature, and the last one is all about the nature of the material. Are we together? Now collecting them. In case now you want to collect those factors, we have to say now change in length is about direct proportion to the original length and change in temperature. This is very important factor that you have to consider about it. By collecting this one and this one, now we have two factors that we depends on it, but inside of those two factors, if now we collect them, we find the change in length is that proportion to the original length and the change in temperature. Are we together until the moment? Now let us see, now we can explain about this equation. How does it happen?